Hello, this is Ms. DB, and today we're going to continue with Chapter 5 and go over Section 3 on medians and altitudes of triangles. So if you've remembered from the last couple sections, we've already discussed what happens when the perpendicular bisectors intersect and the angle bisectors intersect. You get the circumcenter or the incenter. Today we're going to look at a couple other things you can do to triangles, and that is the medians and the altitudes. We're going to see what happens when you make the medians and the altitudes of a triangle and see where they intersect. And median of a triangle and centroid go together, and altitude and orthocenter go together. All right, a median of a triangle is a segment whose endpoints are a vertex of the triangle and a midpoint of the opposite side. This is a median right here. So if you make the midpoint of one side and connect it to the vertex of the other side, that's a median. So you have a triangle, so you can do this on each side of the triangle. And what happens is that, remember the word concurrent, the medians will all intersect at a point. And that point gets a special name, and it's called the centroid. So this point where all the medians intersect is called the centroid. It's always inside the triangle, and it's also called the center of gravity. If you cut a triangle out and create the centroids by connecting the medians to the vertices opposite them, that point right there is where you could balance it on a pencil or your fingertip if you do it just right. There's a theorem about the centroid, and this theorem's a little different than the other ones that we've learned. The centroid is 2/3 of the distance from each vertex to the midpoint on the opposite side. Let me show on this picture what that means. Okay, so here let's draw the one centroid I'm going to do in blue here instead of red. See this centroid from the vertex to the midpoint of the opposite side. This centroid right here essentially is 1/3 of the way from the midpoint and 2/3 of the way from the vertex. If you thought about this line as being in 3 equal parts, then that kind of makes sense. So here's 2 of those parts here, and here's 1 of those parts. So if you know that like this distance is 2, then you'll know that this is 2 and this is 2, so from A to P would be 4. So you can use the centroid in this little theorem to find missing lengths of parts of the triangle. All right, so let's look here. We have, where's LMN? LMN, RL is 21. This length of this segment, the whole thing, is 21. Now we know it's a centroid. How do we know that? Because these are marked that it's the midpoint. So this is the midpoint, this is the midpoint, and this is the midpoint. So R is a midpoint, which means that RL is a median, which means that this is the centroid. Well, if the whole thing is 21, what do they want us to find? LS. If this is 21, then this must be 7, 7, and 7, because 7 times 3 is 21. Or you can go 2/3 times 21. I know the answer is going to be 14. So 3 goes into 21 7 times 2 is 14. So LS is going to be 14. Now why did they tell us that SQ is 4? That had no bearing on this at all, on this problem. It might be used for another problem, but it had nothing to do with RL or LS. All right, so maybe it has something to do with this problem. Now they want us to find NQ. Okay, they're telling us that SQ is 4. Remember that I said that the centroid will break this into 1/3 and 2/3. If this is 4, so is this, and so is this. So the whole segment NQ is going to be 4 times 3, or 12. And NQ, oh, that's what they wanted, is the whole thing. Now, they do it a different way. They do it a really long way. They find that 4 is equal to 1/3 of NQ, and then they multiply both sides by 3. And then they get Q. But I would say, think about this mid-segment as being broken into 3 parts, and if they're giving you 1 part, then you can find the rest pretty easily. Okay, I got another example here. So in this one, ZW is 7. Now, we know that it's a midsegment because, again, this is the midpoint of JL, and it's connected to the vertex opposite it. So we know that that's 7, and then this is going to be twice as long as that one, so it's 7 and 7, so that's 14. So if they're asking us to find KW, it's just 7 plus 7 plus 7, or 7 times 3, so 21. Again, they use this formula to do that, which you're welcome to do as well, or you can just think about that as being broken into 3 congruent pieces. Now in this one, they're telling us also that LX, where's LX? This whole thing is 8.1, and they want us to find this part. So here's the 1 part, and then this is the 2 part. If you take 8.1 and divide it by 3, and then multiply it by 2, you'll get the answer. Now they're going to do some more steps than that. They're going to say LZ is equal to 2/3 of LX, and then they're going to multiply that by 2/3, and they get 5.4. So they'll get the same thing. So you can get decimals for this. All right, now in this example, they're going to go through the steps for solving word problems that are, it's a little bit lengthy, but we're going to go through it anyway. Okay, a sculptor is shaping a triangular piece of iron that will balance on a point of a cone. So we know, I'm going to go back quick, to the centroid. The centroid is the point where it's going to balance, and that's where you make the 3 midsegments and you connect them. What this question is really asking is, what is the coordinates of the centroid? Or what are the coordinates of this? Coordinates of centroid. That's really what this question is asking. So how do you do that? You have to find the midpoint of each segment, and then you have to connect the midpoint to the vertex opposite it, and that point of concurrency, that point where they all meet, that's the centroid. So here's the coordinates of the vertices. That's important information. We have to make a plan, and we already talked about the plan. We're going to find the midpoints. We're going to connect them to the vertices, and we're going to find where they intersect. Now we only have to do that for 2 of them because the 3rd one will intersect at the same place that 2 of them will. So they found the midpoint of 2 different segments. I want to see the graph of this. Is this the graph? No. Oh, they're saying that this one will be a nice straight line. So once you find that point where they all intersect, then you have the centroid. Okay, so here's our midpoints. I'm going to go back to this. And then they say that if you find I wish they had the picture right on here. Its equation is x equals 8. Bn has a slope of 1. Its equation is y equals x minus 3. The coordinates of the centroid are 8, 5. Does that look like 8, 5? My rough sketch gave me the same centroid as they got. Now we're going to do it without all these steps. Okay. This one. We are going to find the centroid of this picture. It's already on there. So here's how you do it. You have to find the midpoint of each side, and then you're going to connect them. Okay, the midpoint of side PR is, the midpoint is found by taking the 2 x coordinates, adding them together, and divide by 2. So 3 plus 6 divided by 2 is 9. 9 divided by 2 is 4.5. And the y coordinate is 4 plus 0, which is 4, divided by 2 is 2. So here's the midpoint. 4.5, here's 5, here's 4.5, 2, right here. That's one of our midpoints. Okay, another midpoint, I'll do QR. The midpoint would be 0 plus 6 divided by 2 is 3. 8 plus 4 is 12 divided by 2 is 6, so 3, 6. 3, 6. Now, notice that when I connect this line to the vertex opposite, it's a nice straight line. You're going to get that in your problems. You're going to get nice straight lines so that it's easier to connect. And now I'm going to connect this one to this one. Okay, the centroid is where they intersect. Also, this one is going to be at a nice straight line too. Let's go ahead and find this one. The midpoint between 0 and 3 is 1.5. 0 plus 3 is 3 divided by 2. And then 8 plus 0 divided by 2 is 4. 1.5, 4. See how this is a nice straight line too? So the centroid, you can tell that the x value of the centroid is on this straight up and down line right here. It's that coordinate right here, 3. So my centroid is at 3, 4. So the triangles that they're giving you are going to help you find an easier job of finding the centroids. We've got some nice straight lines there. Okay, next thing we're going to go over is altitude. So we did centroid. Centroid is when you connect the midpoint to the vertex opposite. The altitude is just another name for height of a triangle. Okay, it's the perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. Okay, so in this triangle, the altitude, it's the black triangle, and the altitudes all connect outside of the triangle. The altitude is not always inside the triangle. And the place at which they connect is called the orthocenter. So that point of concurrency is the orthocenter. So the height of a triangle is the length of an altitude. I want to look at, before we move on to a problem, I want to look at some different triangles here. So if you have a triangle, I don't know, just like a triangle like this. It's okay that the page turned, I think, but I'm trying to not let it. Let's say you just have a triangle like this. The altitude is the height of the triangle. So if you're going to try to find the area of this triangle, you would need to know the height. And the height is always perpendicular to the other side. So that's the height or the altitude of this triangle. What if you have a right triangle? The height is that leg of that triangle. What if you have a triangle like this? The height is usually shown on the outside of the triangle. This is the height. So the height is from a perpendicular to the other side. Now, you don't have to have your altitudes, do not always have to be like parallel to the ground here, perpendicular to the ground. You can find the altitude of this side of the triangle too. So picture this triangle being rotated around. The altitude is going to be like right here. It has to be a right angle. So this is also an altitude of the triangle. Every side has an altitude. And the place where those altitudes intersect is called the orthocenter. The orthocenter doesn't have any special theorems. So all the other ones had nice special theorems that you could use with them and solve problems with them. The orthocenter really doesn't. So the most that we're going to do with an orthocenter is find it. So here's a triangle, and we are going to find the orthocenter of that triangle. So they found the height of the first side, side XY, and they drew that on there. And they're going to find in very much detail the height of another side of the triangle. I hope they're going to show it. Oh, they barely showed it. And they only do this with 2 points. they only find 2 of the altitudes because the third one will intersect at the same spot. So let's go back a little bit to see what they did here. All right. They want us to find the orthocenter. And they've got the vertices and they got it graphed. Now, the orthocenter is found by finding the height, the altitude of each side, and the point of intersection is the altitude. So here is the altitude if you're looking at side XY. The altitude if you're looking at side XZ, let's see, perpendicular would be, oh my, it's hard to see. And this one would be, so they're saying the altitude is going to end up basically being over here. It's hard to find exactly where it's at without doing this. So what they're saying is, okay, graph it, and then the next step is to find an equation of the line containing the altitude from Z to XY. From Z to XY. They know that the altitude is going to be on this line, and they want to see where would it be from XY. XY being over here. And the equation, it's just a line y equals 1. Okay, that's an easy equation to write. Okay, next thing we're going to do is we're going to write an equation of the line containing the altitude from y to xz. So we want to go from here to this line. And we want it to be at 90 degrees and going up through there. I can't draw it, but let's say that's at 90 degrees. All right, so we have to find the equation of that line. So to find the equation of that line, we are going to find the slope of x to z, and then we're going to write the slope in, we're going to flip it upside down and take the opposite sign. So the slope of this line, xz, let's see, this point is 3, -2, and this point was 7, 1. So to find the slope, you subtract the y values, and then you subtract the x values. So the slope of this line is -3 over -4, which is 3/4. The slope of the line perpendicular to that, you flip it upside down, and you take the opposite sign, so it'll be -4/3. That's m of this line here. Now we also have, we're going to write the equation of that line, and the equation of that line, you can either write it in point slope form or slope intercept form, and we need another point on there to do that. So they're saying, well, it's going to go through this point right here at 3, 6. So we could write y minus y1 equals m times x minus x1. That's the equation of a line. I'm going to write it in slope-intercept form though. So to do that, I'll just multiply this through. That -4/3 times -3 would be 4. And then I'll add 6 to both sides. So I get y equals -4/3 x plus 10. That's the equation of this blue line again. Okay, let's write it out here. Okay, now I have two lines, two equations. The one, the horizontal line, which is y equals 1, and here's my new line. You can solve this system of equations. And to do that, you can just plug y is equal to 1 into the other one, set them equal to each other, and you get 1 equals -4/3 x plus 10. Solve that for x, and we get that x is equal to 6.75. That means the y value we already knew was 1. That means the orthocenter is at 6.75, 1, just in front of z, right there. So it's on that red line, we knew that, and the blue line was hard to draw, but mine was off quite a bit. The perpendicular to XZ would be that light blue line, and that intersects right there at 6.751. So I'll help you out on the worksheet when you get to that problem, but that's orthocenter. And again, there's no great theorem that goes with orthocenter like there is for all the other ones. So you'll just have to find it once or twice, and that'll be about all you'll do with the orthocenter. All right, well, thank you very much, and good luck on your assignment. Please let me know if you have any questions.